So uncertainty is something I guess we all deal with a lot. It's the kind of thing, I mean, uncertainty is it going to rain this afternoon, which is often a question we ask here in Scotland. In terms of science and the scientific method, uncertainty is something that we really spend a lot of time working on, because all science is uncertain. It's always contested. So even something like, is the Earth round or flat, is something where you can test it and get more and more evidence, and you can get to the stage with something like that where the chances of it not being a sphere in terms of the Earth is infinitesimally small, but there's always a chance in science of keeping on testing and proving something is real, and that's where uncertainty comes in. So uncertainty, when we apply it to science, climate science is a good example. We tend to have better certainty about what's happened in the past because we can look at events and build up data, but there's also uncertainty the further we go back in terms of reconstructing climate because we're using proxies. And the same in the future. What we try and do when we're looking at climate change, for instance, and what the future will hold, is give a view of uncertainty which is usable. So if we're planning in terms of dealing with sea level rise, and we're saying the sea level is going to get higher in this area, what are you going to do about it? Are you going to build bigger sea defences? We need some idea of uncertainty to allow us to decide whether it's going to be a 10-metre sea wall, or is it going to be a 1-metre one, in terms of what's realistic and what's uncertainty. So we have a language of uncertainty in climate science and science more generally to help encapsulate this. So a good example would be the very likely occurrence of climate change being due to human activity. So that's something that the climate science community came out and said that the warming we've seen in the last few decades is very likely due to human activities, and that actually has a percentage probability, a kind of certainty attached to it of more than 90%. And what that means is that when we're giving advice to policymakers, we can give these kind of indications of uncertainty. So in reality, what we do is we run thousands and thousands of model runs of say, the future climate or the past climate, and we look at what they're all telling us. And so if we've got thousands and thousands, and 90% of them are saying it's going to get 3 degrees warmer or more, then we can say, okay, so it's very likely that the warming is going to be more than 3 degrees under this scenario of emissions in terms of how the world reacts to climate change. And that's really important, because what it means for policymakers and the people who hopefully take note of the science and act on it is that they can see how uncertain things are, but also how certain they are. So if someone said to you, there's a 90% chance that you're going to be run over today, then you probably wouldn't go out the house. And the same with the policymakers. Hopefully they can see that if we're saying, look, that if you go down this emissions route, if we as a global society emit this much greenhouse gas, this much carbon, there's a 90% chance that we'll have warming which is really dangerous, which is more than 3 degrees of warming, then they can act. So we give that uncertainty so that they can feel they can balance the risk. Obviously they have to take into account public opinion, all the other pressures on them in terms of spending on infrastructure and health and all those other challenges in terms of what we do as a society in a national and local level. And what uncertainty gives us is a way to really give that some context and say, if you do this, there's a risk that it could turn out really badly or really well. So it gives some real boundaries to what we're saying in terms of the past, but particularly the future climate.